Hello, good afternoon to all. Is this audible? Hello. Okay. Is the presentation visible? Can you all able to see my screen? Kindly anyone of you unmute your mic and tell me whether you're able to see my presentation.
Yes, sir.
Is the slide visible? Okay. So in today's class, we'll be discussing about the important concepts of GPS constellation, space segment, control segment, and user segment. First of all, what is this GPS constellation is? So before starting this today's class, I would like to clearly tell you that the session is being recorded. So whoever is joining late to the class, they can access it later only. So whoever, if they are joining late, they will be the losers for this session. So we'll proceed with the first topic, GPS constellation. Okay. So this GPS constellation was conceived as a ranging system in order to determine the position of satellites in space to unknown positions on land or sea or in space. So this positioning of satellites marked is continuously being done. Whenever we place a satellite in space, the positioning of that satellite should be marked continuously such that the exact location of satellites or the celestial bodies that we want to determine can be done accurately. So the satellite signal has to be traced continuously such that the transmission time whenever it receives the signal transit period shall be measured with a synchronized receiver. Then the another objective of the GPS is that instantaneous determination of the position of the satellite or the celestial body or the object or whatever you want to track, and the velocity with its precise coordination of time. So anywhere on the earth or anywhere in the space at any time we can easily determine the position and the velocity and its precise coordination using GPS constellation. So this was defined by William Wooden in 1985, where the Navstar Global Positioning System is an all-weather. Just a moment. ஹலோ சொல்லுங்க மேடம். ஆல்ரெடி அவங்க கூகுள் கிளாஸ் உங்களுக்கு போடலையா மேடம்? எனக்கும் கிளாஸ் தான். எனக்கும் கிளாஸ் தான் மேடம். ஆமாம் ஆமாம், செலக்டிவ் இல்லை பேரலா. வேணா நீங்கள் வேணா நீங்கள் மேடம் ஆ மேடம் நம்பர் ஷேர் பண்ணிவிட்டு மேடம் கேட்க சொல்லுங்க. மேடம் மொபைல் நம்பர் இருக்குல்ல? ஆ ஓகே. Yeah, sorry for the interruption. Got a call. So, as the GPS constellation definition was given by William Wooden, the Navstar Global Positioning System is meant for all-weather monitoring space-based navigation system, which was given by the Defense Department of Defense of U.S. military force, such that they can accurately determine the position, velocity, and time with a common reference anywhere on the earth, and that too continuously. So this is what the definition given by this William Uday. So since this Department of Defense is the initiator of global positioning system, there were only primary goals for military. They initially established this global positioning system only for military purposes. So, but as the U.S. Congress with the hello, Arvind, kindly mute your mic. Any doubts? So the U.S. Congress, with the directions from the President of United States, directed the Department of Defense to promote the use of this GPS to civilian users. That means that other than the military usages. So primarily, it led to the development of GPS for civilian structures. So this instrument was employed by a macrometer purely for geodetic surveying. Later, it became commercial with respect to time, as the first GPS were giving us high accuracy geodetic networks. This systems used pseudo ranges, which we called PR in short, PR ranges, which were derived from broadcast satellite signals. So these pseudo ranges were derived from either measuring the travel time of the signal and by multiplying its velocity, or by measuring the phase of the signal. So if the travel time of the signal is being measured and multiplied by its velocity or by the phase of the signal, we can easily find this pseudo range. So this is how the pseudo ranges were being calculated. So both the cases, either by multiplying phase of the signal with travel time or multiplying the velocity with the travel time, in both the cases, the clocks of the receiver and the satellite were being employed. So since these clocks were never perfectly synchronized, the thing is that in one region the time zone was different, in other region time zone was another thing. So as we are facing in nowadays, GMT, Greenwich Meridian Time, and when we see we have a plus 5:30 for Indian systems, minus 12 for US systems. So all these things were taken into consideration, so which were not perfectly synchronized. So instead of the true ranges, they use this pseudo ranges. Okay, where synchronization error were denoted as just a clock error. So that how to minimize the clock error will be seeing in the next few or 2 or 3 slides. Okay. So each of these had three coordinate. Each of the pseudo range systems had 3 point coordinates in the true range. So those 3 point coordinates are your latitude, longitude, and altitude with clock error. And in order to place or in order to get a data from your GPS, at least 4 satellites are required. One is to determine your latitude, another one to altitude, another one longitude, and the fourth one will be taken as a reference of them. Okay, so 4 satellites minimum are required in order to continuously monitor a location 24 hours a day. So this is required. So this became a more complicated solution when we used to measure even the phase also. So this has led to all of the systems in an ambiguity. Okay, so this ambiguity is is an integer number of signal wavelengths such that the model for phase pseudo ranges is determined by an initial bias called integer ambiguity. So integer ambiguity plays a major role in this. So the all-weather global system that was managed by this, we are having three different segments. One is the space segment, the control segment, and third the user segment. What was the role of this space segment? Was that it had satellites which could broadcast only signals, and the control segment would control all the system. It will steer the whole entire GPS system. Whereas a user segment would be having only receivers. It will be having only receivers. So this space segment, as again, the space segment is divided into three categories. One is constellation, second one satellite, then denial of accuracy and access. And in this, the satellites are categorized into the types of satellite categories, satellite signal, operational capabilities. So first of all, I'll show you how are these GPS segments being present. So as you can see the diagram, is this diagram visible? Let me check whether everyone is able to see this diagram. Hello, Rakesh? Rakesh is here. Is this diagram visible?
Yes, yes, sir. No, sir. Now came back, sir.
Okay. Okay. Let me check.
Anubhav.
Now, now,
Yes, sir.
now is it visible?
Yes, sir.
Yeah. So the space segment is divided into, sorry, the GPS segment is divided into three. One is the topper space segment, which is present in space approximately 22,000 kilometers from the surface of the Earth. And we have a user segment where users of different kinds, either the military, aircraft, I'm pointing it, military, aircraft, navigation, user, and even in stars. So these are the different types of users. User segment will be at the Earth. Another thing is that we have a control segment which is also present at the Earth, which controls all the phase segment, user segment, and all the informations, whichever we are going to obtain from the satellite. Okay, so the communication between the satellite, which is at the top in space segment, and the user segment always uses your L band. L band. And from the satellite to the control segment, it uses your L band. Whereas from the control segment to the satellite, it uses only S band. So these are the frequencies that you have seen in electromagnetic fields or electromagnetic spectrum. So this is your diagram for that. So now I'll show you a small GIF such that how these satellites can be viewed. Now see the screen. You are able to see anything? Can anyone of you turn on your mic and tell me what you are able to see?
Yes,
Is
sir.
this, yeah, what you are able to see? Okay, I'll explain this. So we are having a point here. This is the point where the determination of either terrestrial or determination of the land or determination of the information about that particular geographical area is being visualized by different satellites which are being revolving in the space. So you can see they are black or orange, all the colors which are being rotating in some axis are in motion in space in a particular direction, so or in a particular orbit, now to monitor a particular point. So this is the point where the monitoring has to be done. So you can see that as the globe rotates or the earth rotates, the satellite also tends to rotate in a, along the direction of that, and this gives us data about the information of about this particular location. So at any point of time, you can see that there are always minimum 5 visible satellites will be there for a single point of reference. Okay, so these are orbits. This is an orbit, this is an orbit, this is an orbit, all are orbits. So the orbits are, in the orbits the satellites are being placed, they tend to rotate, and as the earth also rotates, they also rotate within a speed such that it completes one revolution in 11 hours 58 minutes. 11 hours 58 minutes, one complete cycle. So when this point is being observed today at, for example, 2:30, I'm observing the data from a satellite 1, and again this will come at after 11 hours 58 minutes to the same point. The satellite will appear here, the same point. So and it goes on. So from that we can easily track the information about that particular satellite as well as about the particular geographical region that we want to visualize. So you can see that minimum 5 visible satellites will be there. Minimum 5 will be there, such that we can get information about that satellite as well as about that particular location also. This is what this is a reference from your Commons Wikimedia, a file from gpsgolden.gif. I would like to acknowledge them also. Since we are using them, we need to acknowledge it. Okay. So here in the black or orange, which is at in the orbits, those are the place where space segment is present. Here we have the point where we want to use or which we want to determine. There we have our control segment as well as our user segments. Then I will stop this GIF. If you want, you can refer it later also by simply clicking this ID. You will get it. Going back to the GPS segments. Next is the constellation. As I said, these GPS satellites are already placed in space with an altitude of about 20,000 kilometers above from the Earth, and a period of approximately 12 sidereal hours. So which is 11 hours 58 minutes. Sidereal period is different from our period. So sidereal period is 11 hours 58 minutes. Okay, the constellation will have the number of satellites with an minimum 24 satellites in a 3 orbital plane constellation inclined to 63° to the equator. Okay, I'll show you this equatorial plane. How do you determine equatorial plane? So then the space, I'll show how do we calculate this 63° inclination with an equatorial plane. I'll show you in a short while in a sketch 4. Don't worry. So the space segment was reduced from 24 satellites to 18 satellites with 3 satellites in each 6 orbital planes. Then this scheme was eventually rejected since it did not provide 24-hour worldwide coverage. So then they had evaluated in 1986 such that this 18 to be increased to 21, so that 3 each in 6 orbital planes can give us good information about the land resources or the earth resources or the space. So nominally we consider that 24 operational satellites with an inclination of 55° would provide us a better evenly spaced planes for better accessing of your information of satellite as well as geo resources. So then the Constellation part, another person, Gravis 1992, had given that he provided full constellation in the sense coverage of the entire location with a global coverage having 4 to 8 simultaneously observable satellites with 15-degree elevation at any day. So if the elevation mask is reduced to 10 degree, 10 satellites will be visible. If the elevation mask is further reduced to 5, 12 satellites will be visible. So this is what the elevation is. I said you just now before. How do I find this inclined equatorial plane? Okay. So you have your satellite in orbits. So these are the satellites in orbit. This is your Earth. And I'm taking a small satellite and I am opening it and I'm showing you what is present. We have solar panels in that. We have two different frequencies. One is L band frequency. Using your L band antenna, we have an S band antenna for S band frequency, such that we can, since it's a satellite, it has to have two different frequencies. One is transferring information from satellite to the control segment, use L band, and receiving information from the control segment, use S band. So we have two bands in that. This is what it is. So coming to the space segment satellites. So the GPS satellites provides a platform for radio transceivers, which has atomic clocks, computers, and various ancillary equipment to operate the system. Here, this equipment of the satellite allows the user to measure the pseudo ranges to the satellite and then broadcasts a message that allows the user to determine the spatial spatial position of satellite. So initially, users were able to determine their position, or which we call as pseudo range, on and or above the Earth by a recession technique. The auxiliary equipments which are present in the satellites consists of some of the solar panels for power supply, a propulsion system for orbit adjustments and stability control. These satellites had various systems like launch sequence number, assigned pseudo random noise code, PRN codes, orbital positioning number, and NASA catalog number and international designation, such that which country has been launched, which country is using this, which country or which part of the world has been controlled over that. So, which is the international designation. NASA catalog number has to be specified because they keep a reference of each and every satellite. So NASA catalog number is mandatory for every satellite systems. And there are some 6 different types of categories of satellites. One is the first one, we'll see the block 1, which we call it as the Californian system. So there were 11 block 1 satellites, which were about weight of 845 kgs, launched during 1978 to 1985. Okay, with the name Atlas F launch vehicle. Okay, since the failure in the 1981, all the launches were successful. Okay, 11 they launched. So in that only one booster was failure in 1981. So this, none of them is a point to be added to our information, that none of the original block 1 satellites is in operation still, because they had only a lifespan of not more than 10 years. Not more than 10 years. So see 1978, see the current date. So 10 years. This is not in operation nowadays. So next is block 2. So these block 2 satellites were having an orbital planes of inclination of 55 degree compared to 63, as I said earlier. So these were fully available to civilian users, whereas block 1 was only meant for military purposes. Block 2 was even given a license to civilians, where some of the block 2 satellites were restricted only for military usages. Okay, so the first block 2 satellite, which costed about $50 million and more than 1,500 kg, was launched from the Kennedy Space Center in 1989. from the Florida, and this had a design of 7.5 years, which could operate over 10 years of operation. So then an advancement of this block 2 came, which we called as block 2A. A represents your advancement, which had a mutual communication capability. Some of them carried even retroreflectors, which could be easily detected by or tracked by laser ranging. So this was launched during 1990s, and as of now, there is no major difference between 2 and 2A satellites. Coming to the next type, which is the fourth type, block IIR, where it's not IIR, it should be spelled as, sorry, it should be block 2R. Block 2R, R stands for your replacement or replacement, which had more than 2000 kg of weight, and this had a cost of about 42 million, which was approximately same as block 2 codes. These were successfully launched during 1997, and they had planned to launch 19 more satellites with a design life of 10 years, with having more facilities for communication and inter satellite tracking. Communication between satellites and satellites or their major goals. So these satellites were launched even after 2005 in order to transmit additional signal components, information about satellite. And this was followed by Block 2F. Block 2F represents your follow on, so which had a weight of 2000 kg, launched with a design life of 15 years from 2007 onwards. So they had equipped this with an improved onboard capabilities, such that inertial navigation systems were being easily augmented on a signal structure. Then the Block 3 satellites were introduced. These Block 3 satellites are being under construction, and the research on the Block 3 satellites are still going on. And we are expecting that this may go beyond 2030 also. So these are the generation of satellites. So next is about the satellite signal. As I said, we are having two different bands of operation of the space segment. One is S band, other one is L band. So L band is the communication between the satellite to the user segment and the satellite to the control segment. So how does it being differentiated? What are its carrier frequencies that we are going to see? So the actual carrier broadcast by the satellite is a spread spectrum signal, just spread spectrum signal that makes it less subject to unintentional jamming. So anti-jamming has been established, as you have studied in digital communication also, spread spectrum concept. So where the signals, when it gets aliasing, or when they are being jammed by a signal or another signal, jamming occurs. So in order to avoid the jamming, we go for DSSS system, direct sequence spectrums, and FHSS, frequency of spread spectrum systems. So similarly here also, the satellites use this spread spectrum techniques, which is used to determine position ranging systems at hydrographic level and even at wireless LANs. The key to the system's accuracy is that it can find all the signal components, which are precisely controlled by atomic clocks. So this atomic clocks lies on the four board time standards, four onboard time standards which are being placed. And for example, if you see a block 2 satellites, these have four onboard time standards of atomic type, two rubidium, and two silicium clocks. The long-term frequency stability of this clocks reaches in 10 power minus 3 and 10 power minus 4 over 1 day. And in future, if hydrogen masses were used, if they are used for even more better stability, it will have a 10 power minus 14 and 10 to 10 power minus 15 over 1 day. So the frequency stability of these clocks. And another point to add to the signal, satellite signal is that high accuracy frequency standards is the heart of your GPS satellite. So that tends to produce the fundamental L-band frequency around 10.23 megahertz. Okay. So this is heart of the GPS satellite, fundamental frequency of L-band. So considering these two, we have a carrier frequencies of about L1 is equal to 1575.42 megahertz for L1 and L2 as 1227.60 megahertz. So which we call it as L54 and L20 respectively. Next is the pseudo random noise. So these pseudo random noise codes are being generated by the pseudo random ranges that determine the measuring travel of times from signal of the signal from each satellite to the receiver. So they consist of two different codes. One is your CA code, which we call it as course or acquisition code, which is available for civilian users. And we have another code called P code, precision code, which is reserved only for the US military and some of the authorized users, some of the authorized can use. So this CA code was designed as a standard positioning service having a wavelength of 300 meters, and this is presently modulated on L1 only on L1. And the precision code, which was designed or reserved only for the US and authorized military users, it had a precise positioning service. So whereas this had only standard positioning service, whereas this had a precise positioning service, having a wavelength of approximately 30 meters. So in this P codes, both the carriers of L1 and L2 are being accessible. So in addition to the PRN codes, a message is also being modulated onto the carriers having the status information of the satellite, the geographical position, and the satellite clock bias and the satellite ephemeris. Next, coming to the operation capabilities. There are two different operational capabilities. First one is IOC, second one FOC. This IOC was given during 1993, where 24 GPS satellites were used with Block 1, Block 2, and Block 2A. Block 1, Block 2, and Block 2A as an initial operation capability. And this was given by the Department of Defense. Whereas this FOC, full operational capability, which also had 24 block satellites, had only satellites in the range of 2 and 2A. 2 and 2A, which was done in 1994. Okay, and this was not declared even before that. Two operational capabilities. Next, in the space segment is your denial of accuracy and access. So what does this denial of accuracy and access states that there are two techniques for the civilians such that they can make use of the full system for navigation or positioning or determining the accurate position. One is the selective availability, another one is your anti-spoofing. So what does this selective availability is meant for is that it is meant purely for your civilian users. So where CA code, pseudo code ranges are being used in the range of 400 meters. This had a navigation accuracy of 15 to 40 meter for positioning, and in order to determine the velocity of a particular object. And the main goal of selective availability is that only a portion of your signals of these bands were available for usage. And the goal of the selective availability is to deny this navigation accuracy to potential adversaries. Having satellite clocks as Sigma process and ephemeris as epsilon process. So what is this sigma process? This is achieved by deterring the fundamental frequency of the satellite clock and a bias that has a direct impact on the pseudo range in comparison with the satellite clock and the receiver clock. Whereas the pseudo ranges are difference between two receivers, where we can eliminate this dithering effect. So next is the ephemeris process or the epsilon process, where the truncation of orbital information in the transmitted navigation occurs such that the coordinates of the satellites cannot accurately be computed. So there will be error in the satellite position. So this error in the satellite position we call it as position error, and this can be minimized for a baseline systems where they are equal to the relative baseline positioning. And the orbital errors also cause your pseudo range errors with similar characteristics, and these errors highly reduce when pseudo ranges are different between two receivers. So when there are two pseudo ranges, two different pseudo ranges with obtaining from two receivers, this errors can be minimized or reduced very easily. Next is about the selective availability. How does it works? So by the specifications given by the Department of Defense, the accuracy of the standalone receivers is given to 100 meters in horizontal position to 156 meters for altitude positioning, and which can have a velocity error of about 0.3 meter per seconds, and in terms of error of time 340 nanoseconds. So this gave us an accuracy of about 95% of probability. So if we want to obtain a 99.99% probability level, the desired accuracy was measured for about 300 meters for horizontal and 500 meters for height or the altitude position. So due to the military effectiveness applied by the differential techniques of National Research Council of US and the National Academy of Public Administration, they turned off this to zero and they deactivated the selective availability for few years. And this proposal was again released back by the directions of presidential in 1996, which had some modifications, which we called as presidential decision directive on the GPS. So based on the recommendations of this PDD, the NAPA and the NRC, this was discontinued within a decade. So then this was not able to, we were not able to use this SC. Whereas coming to space segments, the next, after your selective availability is anti-spoofing, we call it as AS. This was essentially designed for the L band carrier, which used precision codes or the P codes, which is a some form of encryption. So that is given to the authorized users. And this anti-spoofing was given an encryption of modulo 2 summation or modulo 2 addition with an weighted codes of W code. Some weights was given with the modulo 2 addition such that encryption is being done successfully. So the resulting of this, they got it as V codes. So when the anti-spoofing is active, P code will fall on L1 and L2, and it will be replaced by an unknown V code. So which can be either known, sorry, which would be always unknown code to the unauthorized users. So when anti-spoofing is either turned off or turned on, Depending upon that, we can get the V code and we can descramble the original codes. So this was an additional feature as an encryption in anti-spoofing. So the variable influence of anti-spoofing was not in the case of selective availability. So for testing this during 1992 to 1994, the FOC full operational capability was implemented on this, and in accordance with the policy of Department of Defense, the future signal provided a CA on both L1 and L2. And only for military users, they used V codes, which split the spectrum signal as M code. Okay, in they used in military as V code, and they used in civilian as M code. So coming to the next main topic is your control segment. Okay, I'll show you this diagram first. Control segments. So in the control segment, there are you can see a map of Earth. So where some four indications are given. One is a rectangular box. Another one is an triangular in black. Another one is a triangular in white. Another one is your circle, which is your monitor station. So rectangular box constitutes your master control station. Circular represents your monitor station. Antenna in the form of backup, and primary is your triangle. So these are your control segments which are being present at Hawaii. Hawaii is a monitor station. Ascension Island is a monitor station. Diogen Garcia is a monitor station. Quajan is a monitor station. So whereas the master control station is present in Colorado Springs, as well as, yeah, master control is in Colorado Springs. So why I'm showing this is that the backup of this is here, the control segment. Okay. So the control segment consists of these three major: master control station, monitor station, and ground control stations. So what is the operational tasks of this operational control system is that tracking of satellites for information of orbit, time and prediction, synchronization of satellites, uploading of data messages to satellites, imposing selective availability on the selected broadcast signals, performing many non-operational activities such as procurement and launch activities. So these are the operational tasks of control segment. So first of all, we'll see where are these control segments are located and what is its function. First is that a master control station is present at California. Second, another master control station was shifted from consolidated space operations at Stever AFB. Another one it has Colorado Springs, Colorado. So what is this consolidated space operation center doing? It tracks data from the monitor station, calculates the satellite orbit and plot parameters using an estimator, preferably a Kalman filter. And these results are then passed to one of the three ground stations for eventual upload to satellites. So the satellite control system has the responsibility of master controlling station also. So these are some of the five major monitoring stations available: Hawaii, Colorado Springs, Ascension Island in South Atlantic, Diego Garcia in Indian Ocean, and Quajan in the North Pacific Ocean. Each satellites are being equipped with a precise atomic time standard for continuous monitoring of receivers that measure the pseudo ranges of all the satellites. And these pseudo ranges are measured for every 1.5 seconds, to give a 15-minute interval between the data to the master control station. So every 15 minutes gap, they'll send the information about the satellite as well as the geographic position. Next is that it is the official network for tracking and determining the broadcast of the satellite's clock information also. There are there is an agency called National Imaginary and Mapping Agency NIMA, which is used to compute this precise epidemics of up to 14 additional sites. And these networks generally have no part in managing the system. A private tracking by the manufacturer of micrometers was done during earlier 1980s. So globally today, there are so many tracking networks that are being in usage to track any GPS devices. Coming to the ground control stations. These are ground control stations consist, present along with the monitoring stations at the above three places: Ascension, Diogen Garcia, and Convergent as the communication link. So this gets the information from the monitor stations of satellite epidemics clock and gives it to the master control station through a communication link, and they are uploaded to each GPS satellite through the S band. Since S band is the link between satellite to the control station. So then I am showing you an diagram, the duration of the positioning service of satellites from the operational control control system. The block 1 had a duration of 3 to 4 days, block 2 with 14 days, block 2A with 180 days, and block 2R with greater than 180 days. So these satellites perform an 8-hour duty, and they track and give information uh, once a day or twice a day about the particular location or satellite. This is what I had shown you earlier. So next is the user segment. So the user segment is divided into three parts. One is the categories, which is again subdivided into military and civilian. Another one is receiver, which is subdivided into four different types of receivers: coarse acquisition code pseudo range receivers, coarse acquisition code carrier receivers, precision code receivers, and specific Y code receivers. We'll see all those things. First one is the military use. Let me check how many are present in the class. While I'll check it. Only 24 are present. So the user categories. So they are being basically differentiated into two. One is for military usage, second is for civilian usage. So during the Gulf Wars, they used the GPS as an combat devices such that they can easily identify the presence of their enemies' crafts or enemies' war positioning or any material that they want to track. So they had used even in aircrafts, ships, land vehicles, and even in a small group of infantry devices. So it was used in that case. And even in this war, they used the SA selective availability method. So they used a specific handheld course acquisition code receivers were particularly useful in navigating the deserts. So during 1991. So this had a receiver connected to four antennas with a fixed array. For example, we have a corner of a square, so all the four corners antennas were fixed, and they determined the altitude of the array to its position. The- So there are some other examples also placing antennas on the bow, stern, port, or starboard points of a ships to determine the pitch, roll, and position of the each of the vessels. So this was used in militaries. So whereas in civilian, since the evolution of GPS was done only majorly for military purposes, it was later extended to civilians. And the very first navigation was an important concept, such that they could easily conduct surveys of all types of lands, geodetic control surveys, and positioning photo aircrafts, such that mapping can done easily. So, an non-survey civilian uses the GPS as the system in order to control and fleet the management, such that it can be helpful in the emergency services, such as connecting cities, mapping the cities, finding in what location what we have, displaying the city's road system, such that during emergencies it can be useful for the others. And the location of each emergency vehicle had a connection with the GPS system, such that a radio link will connect all the devices of emergency vehicles, which can be rerouted during emergency things. And the tracking of trains, which we are doing nowadays in a small mobile app, train something, I think so, I don't remember, train emulator, or tracking a train, and even hauling vehicles. Those can be easily tracked, which are civilian users. So this GPS were also being used by hikers and boaters to determine their location. Some used both the combination, some of the combinations of the GPS and computer graphics in automobiles, such that good fidelity music systems can be delivered. And even in nowadays in vehicular communication, vehicular systems, this use of GPS is used as a civilian case. Next, coming to the types of receivers, is the first type post acquisition code pseudo range receivers. Here only the code pseudo ranges can be measured. It is usually done by a handheld power device with the use of flashlight batteries. These devices had three-dimensional positioning. One is, as you have seen, longitude, latitude, and altitude. And these receivers had four or more channels that are preferred for applications in order to monitor the satellite ranges for more accurate positioning. So we have a single channel receiver that would be adequate for all these applications, not to determine a fixed location, and eventually we can measure the sequential signals that are being measured in sequences. And this receiver is being basically having a multi-channel receiver type, mostly used by hikers, boaters, and in automobiles also, CA type. So whereas this coarse acquisition code carrier receivers, these code ranges and carrier phases vary from L1. It has only L1. It doesn't has L2. It doesn't has L2. There is no dual frequency data available for this serving in the earlier days. So whereas in the most instruments that we are using will have a minimum 4 independent receiver channels, such that more designs will have which is exceeding 12 channels. So then these receivers performed all the functions in order to determine the time, code ranges, carrier phases, and these informations were being stored in some of the storage devices like laptops, computers, magnetic tapes, memory chips, PCMCIA cards. They measure data which we did not have in this CA type. In CA type, with CA code pseudo range receivers, we don't have a storage of memory. So where in terms of CA code carrier receivers, we had a provision of storing the information in memories. Then this measured an L2 type also in the future, in addition to L1. So where the drawback was only that the SNR was considerably low. It was very low in the CA code measurements on L1. So these receivers were also used in all types of precise surveying, including static surveying, kinematic and pseudo-kinematic technologies. So next is the precision code receivers. These precision code receivers were able to use were being used both on L1 and L2 simultaneously in the absence of anti-spoofing technology. After the usage of this precision codes to the civilians, they had two advantages. One is they were successful during the FTG tests, and it had a measuring capability of 100 kilometers to few centimeters accuracy. So if I want to position a satellite or position a object, the accuracy was very much higher, such that from few centimeters to 100 kilometers, they were able to easily detect whatever object is being present or whatever crafts or navy's ships or aircrafts which was to be determined can be done easily using this P-type codes, which was implemented in 1990s. The second advantage is that this measures length kilometers with a small amount of data by using linear combination method of measuring the phases of L1 and L2 alone. Technology in P codes, which we call it as Y codes. Okay. So with the evolution of adding this anti-spoofing technology in P code, a new terminology or a new type of code called Y code was introduced. So this Y code had the basic structure of P code with anti-spoofing technology. So this operated in a codeless or quasi-codeless systems, making the carrier phase data and code pseudo ranges for L2 frequencies easily. So this gave us more accuracy in terms of tracking. So this were the performance characteristics of where signal squaring, cross correlation, code correlation, and the Z tracking technique. So these were the major advantages in this Y code. So which led to a specific code called Y codes. So this Y code receivers provides access to the P code with anti-spoofing technology in it. So this can be easily derived with the code ranges and phases on the L1 and L2 signals by the P-code correlation technique. Since this code is accessed only on auxiliary output chips AOC in each receiver, that allows only the decryption of this. So encryption in the form of anti-spoofing with P code leads to Y codes, and this decryption can be done only by using an AOC chip in the receiver channel. So for the time being, these Y codes are not accessible except DODs. Only the Department of Defense has the authority to use Y codes. The remaining are open to all. So next is about the information service provided by these user segments. So several government organizations and private organizations have an provision to know about the GPS information or status of the GPS information right from day one to day last, even to the military and to the civilian users. So this information contains what? What does this information contain? So this information contains about the Constellation status report, scheduled outages as given by the DOD notice to Navstar users. So notice advisories to Navstar users had formulated this such that only these informations are being given to civilians. Constellation status report and scheduled outages. So the orbital information in the form of Almanca suitable, it is a type of information only where the table of GPS informations are available, such that the GPS coverage, satellite visibility predictions, and precise epidemics suitable for precise vector computations can be done easily. The general information provided by the GPS papers and meetings are open to all under the official information of NIS, Navigational Information Service, which was formerly called as GPS Information Center. So whenever a civilian or a person intend to know about the information of satellite information of about any celestial body or tracking information, they had to approach the GPS Information Center. Now it has been transformed to Navigation Information Center, which was run by US Coast Guard, where they used to monitor 24 hours a day over a telephonic information service. So if you want to check, you can use these dialing numbers of US to get your recordings of GPS status. GPS status voice recording can be obtained by using this technology. Okay, it was during 1990s. So the comprehensive information. What does this information service include? Is that precise epidemics, satellite clock parameters, as provided by the CBIS, Central Bureau Information System of International GPS Service for Geodynamics, which is located at US JPL, Jet Propulsion Laboratory. So this is also accessible through internet via some anonymous files called FTPs, file transfer protocol. And at last, what are the information that we can get from them about the GPS is that Navigational Information Service, NIS, Australian Surveying and Land Information Group, AUSLIG, which is available in this website. You can get the website, Australian Information, Canadian Space Geodesy Forum, CanSpace, which is the US system, German GPS Information Observation System, GIBS can be obtained from this, Germany, and the Russian Interstate Navigation Information Center, INIC, so which you can get from this website is not given. So the NIS information can be obtained from www.navcen.uscg.mil. These are your user segment information. Next is your references. Any questions, doubts in this presentation? Minutes. Like that, we'll go for the next presentation. I think you all are able to see the screen. Yeah, is it audible? Hello, is it audible? Yeah, can anyone tell me what is the frequency or what band is used from the user segment to the satellite? What band is being used? Anybody can unmute your mic and give the answer. Just two simple questions. You all are able to see the screen? Is the screen visible? Okay, I'll ask any one of you. I'll ask any one of you about what is the frequency band between the frequency band being used from user segment to satellite. What band we are using? Uh, Lalita, Lalita is there. Lalita, turn on your mic, please.
Sir,
You are able to see the screen.
yes, sir.
What you are able to see?
Satellite control segment, user segment,
Yeah, yeah. I want just one answer. Uh, what is the band being used in this question mark? What band is being used between user segment and satellite? There are two bands. I'll give you options. One is S band, second one L band. Out of these two, I'll give you label A option and B option. Which one will suit here? I gave you two options. Whether it is right or wrong, no issues. You tell me which band will suit satellites
L band.
information, and I'll draw the diagram. Arrow now. L band. Yes, it's correct. L band is used here. Okay. Can you tell me for information from satellite to control then control segment from the two options?
L band, sir.
What is the band? Is also again L band. So correct. Now I'll give you another one. Here we have controlling. So this is always yes band. Uh, Thank you, Lalita. You can mute your mic. No issues. Thank you for the answers.
Okay.
Always from this you can see that always the user segments lies as your receivers only, so they cannot transmit as a user segment. So whereas the control segment has control over the satellite as well as it gets the data from the satellite and gives the data to the satellites. So whereas user, it is at the ground station, will always be a receiver. So for in order to illustrate that only I had drawn this diagram and I showed you. Another interesting question and that I'm going to ask is to Jayant is there? Jayant? I think Jayant is the first roll number for global positioning system. Jayant? Jayant is absent. Jayant is available. No Jayant. Jayant is available or not? He's absent for today's class. Okay, I'll ask. Akhil. Akhil is there? Akhil.
Yes, sir.
Akhil, yeah. Uh, can you give me? I had drawn a diagram here, right?
Yes, sir.
In the satellite. I want just what could be this? I'm putting a question mark. See that? What could be this in a satellite? I'm putting two question marks. You're able to see
Yes, sir.
what is this? We have a satellite. I had drawn some small boxes on the two sides. What could be that? I'll give you options also. Don't worry. I'll give you option. I'll write the options here. This. I'll write the options also. Propulsion unit, which is first option. Second one, power supply. And third one, solar panel. Okay, I'll erase this. This is only two options I'll give you.
Solar panel.
Option, the highlighted question marks are
Solar panel. Solar
solar
panel.
panel. Solar panels. Okay. Yeah, okay, very good. Thank you. So from this, I had understood that most of you are listening in class rather than sleeping. Okay. Okay. So this is what the diagram that I had drawn. You're able to see this? Here we are having a satellite, a base station, and a rover. So this base consists of your control segment, and the rover is your moving object or a stationary object that we want to determine. So in the next class, we'll be seeing about this differential GPS, static and kinetic positioning, datum 2D and 3D transformations, dilution of precision factor. Okay, so these are the things that we are going to see. So don't worry. So, for the being today's class, that's all. Uh, I would like to take attendance, so kindly await. Kindly await. I'll take attendance. I'll stop the recording.